Hello again, everyone. So I'm here now to discuss related rates or time rates problem for differential calculus, application of differential calculus. So let's get into it. So for number one, for our first problem, we have a 15-foot ladder. This is quite a popular question when it comes to time rates or related rates. So a 15-foot ladder is resting against the wall. So the bottom is initially 10 feet away from the wall and is being pushed towards the wall at a rate of 1/4 feet per second. So that's also 0.25 feet. So 0.25 feet per second. So how fast is the top of the ladder moving up the wall 12 seconds after we start pushing? Okay, so let's just draw the figure. So if that is a ladder, okay, so it will look like something like this, right? Let's make it bigger. There. Okay, so what will happen is this is the wall. So our ladder, so this is the ladder. Okay, so this is the ladder. This will be your ladder. Okay, and this is the wall. Here is your wall. And of course, this one is your ground. It's your ground. Okay, so what will happen here is a 15-foot ladder is resting against the wall. So this is the ladder is resting against the wall. So of course, that means this is 15 feet. Okay, this is 15 feet. Let's just yes. So this is 15. Okay, 15 feet. And the bottom is initially 10 feet away from the wall. So this is 10 feet. Okay, this is 10 feet. Wall and is being pushed towards the wall at a rate of 1/4 feet per second. So the ladder is being pushed towards the wall. So this ladder is being pushed here, okay, by 1/4, or I can just write it as 0.25. It's just the same. 0.25 feet per second. Okay, so how fast is the top of the ladder moving up the wall 12 seconds after we start pushing? So what will happen here is, while of course if the ladder is being pushed here towards the wall, of course this, let's just call this your Rx, and let's just call this part Y. Okay, since that is the y-axis, is x-axis, and let's say that this is our this is our z. Okay, so that's xyz. Okay, so what will happen here is, while the x, or the base of the ground, or the ground, is being pushed, the ladder is being pushed onto the wall, the y increases. Okay, so the y increases. Therefore, what will happen here is that is 0.25 feet per second. The change of the ladder with respect to the wall is 0.25 feet per second. Therefore, we can say that since this is dx, that will be our dx over dt. Okay, so now we are required to find, we are required to find we are required to find what? How fast is the top of the ladder? So top of the ladder moving up the wall 12 seconds after we start pushing, 12 seconds. So we are required to find the change of y. Therefore, that is dy over dt. Okay, so we don't know this one. So this, the unit of this one must be in feet per second. Okay, but we have a condition that is at the time is at equal to 12 seconds. Okay, 12 seconds. Now what will happen here is, first, you must be able to relate xyz in one equation. So obviously this is a right triangle, right? So for the right triangle, of course, the most popular formula is we have the use, of course, the Pythagorean theorem. Okay? You must be able to relate xyz in one equation. Therefore, using Pythagorean theorem, you will just have here x squared plus y squared, that is all equal to z squared. So you notice here, if you will push the ladder towards the wall, this will be no longer 10 feet. It will change, right? And as you push again the ladder to the wall, towards the wall, the y will not be still the same. But of course, the ladder will still be 15 feet, and it will not change. Therefore, we can say that z z is constant. Okay, z is constant. Therefore, if z is constant, when we derivative this, we'll take the derivative of this one, of this equation, that x squared plus y squared equal to z squared. The z squared must be equal to 0 because z is a constant. Okay, so taking the derivative of this one, you must have here, derivative of x must be 2x dx over dt. Okay, of course, the derivative of x is dx. Don't forget the dx over dt. Okay, dt. Now that is plus, of course, the derivative of y squared, that will become 2y. Of course, that is the change in y over dt. And that is all equal to derivative of z squared, since z squared is constant. Derivative of constant is 0. Now, common 2 is common. We can now cancel this out. So we'll just left with x dx over dt plus y dy over dt. Now we are asked to find dy over dt, right? So we have to isolate dy over dt here. So isolating dy over dt, you'll have transpose. So you'll have your transpose, that will become negative x. Okay, that's dx over dt all over this one, y. Now, what is the value of x? Remember that x must be 12 seconds later. Therefore, if it is moving at 25.25 feet per second, and as you can see that, um, as the ladder again is being pushed towards the wall, x decreases, right? X decreases. Let's just put it x decreases, right? If x decreases, that means this 0.25 must be negative because it is decreasing. So dx over dt must be equal to negative 0.25, okay, feet per second. That's feet per second. Okay, but of course, the value of x now will be, x must be equal to what? So this is just the same with, if you will just apply a little bit of physics here, what will happen here is, of course, for the physics, we have the most basic formula. We have S equal to Vt, right? S equal to Vt. We have the distance, the velocity, and the time. But now, the distance here will be x. X must be equal to, what is the velocity of x? So the velocity of x, of course, that is 0.25. So that is, but again, that must be negative. So you can just neglect the negative as of now because we're just looking for the velocity. So we can just use 0.25. Okay, 0.25, and how many seconds? That will be, 12 seconds times 12. Okay, Therefore, at x must be equal to what? That is 12 divided by 4, that is 3. So that is 3 feet. So it will become now 3 feet after 12 seconds. Now we already have the value of x. We have the value of dx over dt, which is 12.25. That's negative. And for y, do we have a value of y? No, we don't have the value of y, but we can get the value of y. So at, again, that remember that at t equal to 12 seconds, 12 equal to seconds, x squared plus y squared, going back to the original formula, this one, at t equal to 12 seconds, we have x equal to 3 feet, right? And of course, z is equal to constant. Therefore, that is still 15 feet. Okay? Therefore, from this Pythagorean theorem, isolating y to find the value of y, after 12 seconds, you'll have the square root of z squared minus x squared. Therefore, here you'll have here 15 squared minus 3 squared. Right? So that will become 15 squared. Let me just use my calcu. That is square root of 216. Right? Square root of 216, or this is equal to, so y now is equal to 14.6969, or we can just use 14.7. 14.7 feet. And then all you have to do is substitute, use this formula, this one, to find dy over dt. Use y equal to 14.7, dx over dt is 0.25, and x is equal to 3 feet. So substituting all those values, you'll have here dy over dt is equal to negative x. Value of x is 3, so that's negative 3, times dx over dt is this one. So you'll have here negative 0.25, okay, 0.25 all over this one, 14.70. Therefore, dy over dt now will just simply be equal to, that's negative negative, that will now be positive. That is the 0.75 divide 14.7. 14.7. That is just 0.0510. That is 0.0510. And of course, this is feet per second. And this is your answer. Okay? And that's all for number 1. Okay, so let's move on to number 2. Okay, so we have here the second problem. So a tank of water is in the shape of a cone, is leaking water at a constant rate of 2 feet cube per hour. That's 2 cubic feet per hour. So the base radius of the tank is 5 feet and the height of the tank is 14 feet. So at what rate is the depth of the water in the tank changing when the depth of the water is 6 feet? So if that is a cone, that will look like something like this. But I must be able to rotate this one. There you go. Let's put it down here. Okay, so for that, okay, so we have the base radius of the tank is 5 feet. Therefore, if this is the base radius, okay, this is radius, right? So this is 5 feet. This is 5 feet. And the height is 14 feet. So from here to here, it must be 14 feet. Okay, that's 14 feet. Now, at what rate is the depth of the water in the tank changing when the depth of the water is 6 feet? Now, first, what is this 2 feet cubic per hour? As you can see, that is in cubic. If that is a cubic, therefore it must involve a volume. Therefore, that is the change in volume with respect to time, because we have here hour. Therefore, our given here, okay, let's just put all the given. Given is equal to what? 2 feet, so that's dV over dt, or that's the change of volume, since that is cubic, must be equal to 2, that's in feet cube per hour. But as you can see, that is leaking water. Therefore, it causes the water to decrease. Therefore, this must be negative. Okay? Now we have 5 feet as a radius and 14 feet. So at what rate is the depth of the water changing at when the depth of the water is 6 feet? Therefore, we are required now to find what? Depth rate. At what rate is the depth of the water in the tank changing? So the change in depth. So depth is also the height, right? So we can have the change in height with respect to what? Of course, with respect to time. So we'll have here dH over dt. Okay, that must be dH over dt. Okay, and since that's dH, that's height, that must be feet with respect to time with rest. So since this is in hour, what we will get here must be also in hour. Okay, but we have here a condition at depth of water is 6 feet. Therefore, your H must be 6 feet. Okay, 6 feet. Now, of course, in order for you to get a we must be able to use dV over dt. So for us to be able to use dV over dt, that we must have now we can have now the solution, okay? My solution, you must have you must know the volume of cone. So remember that the volume of a cone, that is just 1/3 of the cylinder, that is 1/3, don't forget the pi, and r squared h. Okay? But if we will derivative this, if we will perform here the first derivative, of course the derivative of v will be dv over dt. But for this side, for the right side, we still have two variables. We have r and h. Therefore, we must be able to make this only one variable. But the question is, which variable? Is it in terms with r or in terms of h? Now, as you can see, we are looking for dh over dt. We are looking for dh over dt, right? So this is dh over dt. Now, in order for you to have a dh over dt, or you must be able to differentiate or perform derivative with respect to h. Now, again, my question is it in terms of h or in terms of r? Now, if you will have here only in terms of r, therefore h will be eliminated. Therefore, you only have here in terms of r. Therefore, you won't have any. You will, even if you differentiate this or you will perform derivative here, and the right side only contains r, you won't have a dh over dt. Therefore, this must be in terms of h, and r must be eliminated. What will happen? How will we do that? Now, from this, since this is, let's say this is the center, right? Okay. Since if that is the center, okay, let's just say this is the center, right? If that is the center, that is 5 feet. Now we are asked to find a 6 feet, right? At 6 feet. So if that is 6 feet, so the water must be around here. Okay? And let's just call this from here to here. Okay? Let's just call this H. Okay? And that is a 6 feet. Of course, if this is H, your R now from here is no longer 5 feet. So this must be different. So that is R. Okay, so using this triangle, this right triangle, obviously this is a right triangle. you'll have something like this. Okay, let's just rotate this one by 90. Nope. Another one. Flip horizontal. There you go. Okay. So recreating this triangle. Okay. So you'll have here this one, and then this will be 5. Okay, this will be 5, and this is your R. This is your R, and the whole will be 14. This is 14, and this is H. That is H. The depth of water must be H. Okay, so from this triangle, we can use here RAP or similar triangles. Similar, okay, similar triangle. Okay, similar triangles. So that is height to radius. Okay, height to radius. So what will happen here is the ratio of height to ratio of radius. So what will happen here is the big, as you can see, this is the first triangle. Okay, this is the first triangle. This one. Okay, this first triangle and the second triangle will be the whole triangle. Okay, so what will happen here is like this. So the height of the small triangle is h, right? So you write here h over the height of the big triangle. So the height of the big triangle is 14, right? So 14, and that is also equal to the ratio of the small tri of the radius ratio of radius. So radius of the small triangle, the radius of the small triangle is r, right? So r, and then the radius of this big triangle is 5, and there you go. So since we have to isolate, we have to eliminate r here, we have to isolate here r. So isolating in this equation the r now will be equal to 5 over 14 h. Okay, let's say this is our equation 1, and this, what will you do here is substitute, no? Okay, substitute to equation 1. So you'll have v now will be equal to 1/3 pi r squared, again this, that's 5 over 14 h, don't forget the squared, times h. Okay, so simplifying that, you'll have, that will become now 25 pi, right? That's 25, that's 5 squared, so that's 25 times pi. Okay, times pi, and this will become 3 times 14 squared. 14 squared, and that is h squared times h, that is h cubed. Now from here we can now perform derivative, because we only have now, we were able to express this, the volume of the cone, into one variable only, which is h. So now taking the first derivative, we'll have here dv over dt, which is a negative value. We'll have 3 will go down, right? So 3 will go down here. So you'll have here 3 times 25 pi all over 3 times 14 squared. That's h squared, because that will become now 3 times 3 minus 1, right? H squared, and of course we don't forget the derivative of h is also dh over dt. As you can see, we can now cancel out this. That's 3 over 3, that's just equal. So we can factor out, we can cancel that out, and then all you have to do is just isolate dh over dt. So what will happen, 14 will be cross multiplied to dv over dt. So dh over dt must be equal to, of course, the dv over dt, which is a negative value, times 2, what? 14 squared. 14 squared, no, not h. Sorry about that. 14 squared all over 25 pi h squared. Okay, then substitute the values. Of course, dv over dt, you already have a value for that. That is negative this one. That's negative 2. So negative 2 times 25 pi times what's the height? We already have a given height that is 6. So this must be 6 squared, then 14 squared. Okay. So simplifying that, you will have, of course, that must be negative. If you will simplify that, you'll just have negative 98, okay, over 225 pi. Okay. That's 225 pi, and that is in feet per hour. And that's your answer. Okay, so let's move on to the next problem. Okay, so for our third problem, we have here two people are at an elevator. So at the same time, one person starts to walk away from the elevator at the rate of 2 feet per second, and the other person starts going up in the elevator at the rate of 7 feet per second. So what is the distance between the two people changing 15 seconds later? Okay, so what will happen here is we have an elevator. Okay, so let's just draw an elevator. So let's say that this is the elevator. Okay, and there are two persons walking from the elevator. So what will happen here is we have, let's just put a ground, okay, for your reference. Okay, and then what will happen here is there's a person going away or walking away from the elevator, and another person is going up, right? So if 2 feet per second, so the at the same time one person starts to walk away from the elevator at the rate of 2 feet per second. So walking away, so this is 2 feet per second, so that is the rate of this person, they say. And the other person starts going up in the elevator at the rate of 7 feet per second, so this is 7 feet per second. Okay, so what will happen here is, if I will draw the their distances after 15 seconds, it will look like this. Okay, so this is the traveled by the man in the elevator. Of course, that is a straight line. Okay, so that is a straight line, right? Okay, so that's a straight line. Now, so another man walks here again, walks going walking away to the elevator. So he walks here. They have the same starting point, right? So if they have the same starting point, they will just produce a right triangle. So this is a right triangle. Now we are asked to find uh, what are the distance between the two people changing 15 seconds later. So the change in distance, we are asked to find the change in distance. So if I will connect this to here, you will be able to create a right triangle. Okay, so 7 feet per second. So after 15 seconds and you are traveling 7 feet per second, so let's just call this again, this is, of course, let's just call this is your y and this is your x, and of course this is our z. So so at t equal to 15 seconds, oops, 15 seconds, right? What will happen here is your x will be how much? That is x2. So 2 feet per second times 15 seconds. So that's 2 times 15. So your x will be equal to 30 feet. Okay, 30 feet. While your y will be just 7 times 15. So that's 7 times 15. So that will be 90, 105, 105 feet. Is that right? Okay. Therefore, you will be able to compute for z. So your z, so again, you have to be able to relate x, y, z in one equation. So use Pythagorean theorem, right? So use Pythagorean theorem. So use Pythagorean theorem, PT. Using Pythagorean theorem, you'll have here z, right? Z squared is just equal to x squared plus y squared. Okay, so if you will differentiate or derivative this one, therefore this 2 feet per second, so this is moving, of course, the change in x will be 2 feet per second, so that is dx over dt. This is equal to 2. I will no longer put the unit. So your y will be 7 feet per second. So the y changes 7 feet per second. Therefore, your dy over dt is going up. So div must be equal to 7. Okay, so differentiating this one. Okay, so perform first derivative. So performing first derivative here, you'll have 2z, of course, and of course the derivative of z is dz over dt equal to 2x dx over dt plus 2y, and that will become dy over dt. Okay, so what will happen here is we are asked to find the change in distance, changing distance between the two people. Okay, so the distance between the two people is z, therefore the change of z, therefore we are asked to find this one, dz over dt. So you can see we can cancel out 2, they are common, and we can just isolate dz over dt. Therefore you'll have here dz over dt must be equal to x dx over dt plus y dy over dt all over this z, right? All over this z. And all you have to do, we still don't have the value of z, but at t equal to z, at time equal to 15 seconds, we can solve for z. Z is just equal to the square root of x squared plus y squared, right? And this will be equal to square root of 30 squared, this one, and plus 105 squared, 105 squared. So z now will be equal to, let me just use my calculator, plus 105, 105 squared, and taking the square root of that, you'll have 109.2. You'll have 109.20. This must be in feet. Okay, so all you have to do is substitute 109.2 to z, and this 30 feet to x. Y is 105. Dx over dt is 2, and dy over dt is here, 7. Okay, so calculating dz over dt, calculating or substituting the values, x is equal to 30 times dx over dt is 2 times 2 plus now y is 105. 105, okay, times and dy over dt is 7 all over. Now value of z is this one, 109.2, and then you'll just get your final answer. Therefore your final answer will be 60 plus 7 divide 9.2, that is 7.28. You just have 7.28 feet per second. Is that per second? Yeah, that's per second. And that is your final answer. Okay, so for number 4, we have a thin sheet of ice is in the form of a circle. So if the ice is melting in such a way that the area of the sheet is decreasing at a rate of 0.5 square meter per second, at what rate is the radius decreasing when the area of the sheet is 12 square meter? Okay, so if that is a circle, let's just draw a simple circle. So that is a circle, okay? And we have here a given of, let's just write the given. Given is what? We have zero point 0.5 square meter per second. Wait, that the area of the sheet is decreasing at the rate of, so that is a rate. So area, change of area with respect to time. So that is dA over dt. This must be equal to what? 0.5. Remember that that is decreasing. Therefore, this must be negative. This is 0.5, okay, square meter per second. Per second. So we are required to find, we are now required to find at what rate is the radius decreasing. So radius decreasing when the area of the sheet is. So rate of radius with respect to time. So that must be dr with respect to time, dt. Since again that is decreasing, we are expecting this must be also negative. So this must be meter per second. But we have here a condition at when the area of the sheet is 12 square meter. So area or A must be equal to 12 meter or square meter. Okay, so now we can have our solution. This, okay. Okay. Okay, so for the solution, um, in order for us to have a dA over dt, we have to get the area. But of course, we know the area of a circle. Area of a circle is just simply A equal to pi r squared. Now, derivative. Now, taking the derivative of A, of course, that's dA with respect to time. That's dA over dt equal to derivative of this one, it will become 2 pi r. Derivative of r, of course, that is dr over dt. Now we are looking for dr over dt, right? So all we have to do is isolate dr over dt. So isolating that, so 2 pi over r will be divided by or cross multiplied to dA over dt. So dr over dt, this is equal to, this is dA over dt all over 2 pi r. The only problem is we don't have any value for r, but we know, oops, mhm, but we know that area must be equal to 12, right? 12 meter this one. And so what all we have to do is just use this 12 here. Okay, so you'll have your 12, that's the area, equal to pi r squared. Then find the value of r here. Find r. So finding r, you'll have that's 12 over pi equal to r squared. Or r will just simply be square root of 12 over pi. Square root of 12 over pi. So now we have the value of r, and we also have the value of dA over dt. Then all you have to do is just substitute it here. Okay, so substituting that, you'll have here dr over dt is now equal to negative dA over dt. Remember that is negative. So that is negative 0.5 all over 2 pi square root of 12 over pi. If you will now simplify that, you'll just get an answer of mm, what's that? An answer of square root of pi over 4 pi square root of 12. Yeah, that must be negative. So simplifying that, you'll just have square root of pi. Square root of pi will go up, and then 0.5 is also 1 half. So that's 2 over 2. So you'll have here 4 pi square root of 12. The square root of 12 is equal to 4 times 3. So you will be able to bring out 4 again. So you can also have dr over dt is equal to bring out that's 4. 12 is 4 times 3, so times 2. So you can have your 8 pi square root of 3, and then square root of pi. And don't forget that this must be what, meter per second. And that is your answer. So I guess that's all for this related rates problem, or we can it is also called time rates problem. So again, thank you to all who watched my video, and thank you for the support, and I'll see you on the next one. Bye.